हेलो एवरीवन, वेलकम टू स्मार्ट एजुकेशन। आज हम करेंगे क्लास 10 का चैप्टर नंबर 1 विच इज़ रियल नंबर्स। लेकिन रियल नंबर स्टार्ट करने से पहले हम एक क्विक रिकैप करते हैं अबाउट टाइप्स ऑफ नंबर्स। हमने बहुत सारे टाइप्स ऑफ नंबर्स पढ़े हैं, जैसे नेचुरल नंबर्स, होल नंबर्स, इंटीजर्स, रैशनल नंबर्स, इरैशनल नंबर्स। सो लेट्स हैव अ क्विक रिकैप। अगर मैं यहाँ नंबर्स लिखूँ 1, 2, 3 सो ऑन विच आर ऑल पॉजिटिव नंबर्स, तो इनको हम बोलेंगे नेचुरल नंबर्स। अगर मैं इसकी काउंटिंग ज़ीरो से स्टार्ट करूं तो ये बन जाएगा होल नंबर्स। और अगर मैं इसमें नेगेटिव नंबर्स भी जोड़ दूं, -1, -2 एंड सो ऑन, तो ये सारे मिलके क्या बन जाएंगे? दे विल बिकम इंटीजर्स। अगर हम इन नंबर्स को फ्रैक्शंस में लिखते हैं, जैसे 4/5, 2/9, तो ये क्या होते हैं? यस, दे आर रैशनल नंबर्स। और अगर हम स्क्वायर रूट्स की बात करते हैं, जैसे √2, √5, तो ये क्या होते हैं? दीज आर irrational numbers. And all these numbers together are actually together called real number, जो कि हम अब पढ़ने वाले हैं। Okay, now it's chapter में first topic is HCF and LCM. So let's understand them. HCF stands for highest common factor. तो अगर हमें दो नंबर्स का HCF निकालना है, वेरी इजी मेथड, उन दोनों के सबसे पहले हम फैक्टर्स निकालेंगे। उन फैक्टर्स को देख के हम उनके कॉमन फैक्टर्स निकाल लेंगे जो दोनों में कॉमन हो, और जो कॉमन फैक्टर्स की लिस्ट आएगी उसमें जो सबसे हाईएस्ट होगा दैट विल बी द HCF। Simple. Similarly, LCM is least common multiple. तो इस केस में हम मल्टीपल्स निकालेंगे दो नंबर्स के, फिर कॉमन मल्टीपल्स की लिस्ट बनाएंगे कि उन दोनों में जो कॉमन मल्टीपल्स हैं, और उन कॉमन मल्टीपल्स में जो सबसे छोटा नंबर है वो तो हमें दिख ही जाएगा। दैट विल बी द LCM ऑफ द numbers. Okay, so now let's do a question. Question says find the HCF and LCM of 6 and 20. So let's divide this question into two parts. First part we'll find the HCF, and in the second part we'll find the LCM. So as I shared just now, what is HCF? First we'll find the factors. Factors of 6 and factors of 20. So let's write down factors. अब जिन बच्चों को ये याद नहीं है कि फैक्टर्स क्या होते हैं, तो फैक्टर्स वो नंबर होते हैं जो इस नंबर को डिवाइड करेंगे। तो 6 किससे डिविजिबल है? 6 is divisible by 1. Obviously 1 is a factor of all the numbers. 6 is divisible by 2. 6 is divisible by 3, and 6 is divisible by itself. So these are factors of 6. Now let's find factors of 20. Again, कौन कौन से नंबर्स हैं जो 20 को डिवाइड कर सकते हैं? Of course 1, then 2, yes. 3 cannot divide it. 4, yes. 5, yes. Then 6, 7, 8, 9, no. 10, yes. And then the number itself. So these are the factors of 6 and 20. Now let's find the common factors. Can you see common factors? 1 here and 1 here, 2 here and 2 here, and that's it. 1 and 2. So we can say that common factors are 1 and 2. Now, as I told you, this is highest common factor. So which is the highest common factor? It is 2. So we can say that HCF is equals to 2. Clear? Now let's find the LCM. Again, now we need to see the multiples. अब multiples क्या होते हैं? फैक्टर्स तो वो होते हैं जो उस नंबर को डिवाइड करते हैं, मल्टीपल्स वो होते हैं जो उस नंबर के टेबल में आते हैं। सो अब हम कितने लिखेंगे? लेट्स राइट डाउन 5 फर्स्ट। ओके, सो 6 के टेबल में 6, 12, 18, then 24, 30. Let's write down 10. 36, 42, 48, 54, and 60. Yeah. So now let's write down the multiples of 20. Multiples of 20 are going to be 20, 40, 60, 80, 100, 120, 140, 160, 180, and 200. Okay, so what are the common multiples? If we look at it carefully, common multiples are 60 and no one else. So we can write down common multiple as 60. Now there is only one number, so this is the only least number. So we have LCM as 60. I hope this concept is clear. This is very, very simple. You just need to follow a simple procedure. An important thing. You know, this method of finding HCF and LCM is called. What is this method called? Yes, this is called prime factorization because we are factorizing them. So this method is called prime factorization. Now let's see a relationship between the HCF, LCM and the numbers. The relationship says that the product of the numbers is equal to the product of their HCF and LCM. So let's verify it for the question which we just did. So in that question, our numbers were 6 and 20. Our HCF was 2 and LCM was 60. So let's see. Now A into B, which is 6 into 20, will give you the answer as 120. And HCF into LCM will give, it is 2 into 60, will also give the answer as 120. So C, they are correct. So this relationship is true for two numbers. There's also a relationship for three numbers, but that is not in our course. So we need to remember this relationship between the numbers and their HCF and LCM. Now let's do a problem based on the relationship. The question is that if the HCF of 306 and 657 is 9, then find the LCM. Now let's use the relationship. Relationship is A multiplied by B is equals to HCF multiplied by LCM. So our numbers are 306 and 657. HCF is 9 and we need to find the LCM. So we know 9 is getting multiplied. अगर हम इसको shift करेंगे दूसरी side पे, so it will divide with these numbers. So we'll get the LCM as 306 into 657 divided by 9. I'm not doing the calculation part. I'm skipping that. You can show the calculation. Your final answer is going to be 22338. So this will be the LCM of these. After HCF and LCM, the next important topic in this chapter is to prove that square roots are irrational. So let's start with the first one, the simplest one, which says that prove root 2 is irrational. So we'll begin this proof using an assumption. Let root 2 be rational. We are assuming that it is a rational number. Now, all of us know that rational numbers can be written in the form of p by q. So, we can write root 2 as p by q. Let's take q to the other side. So, this becomes root 2q equals to p. Now, let's square both the sides. So, we'll get 2q square equals to p square. But did you notice that something multiplied with 2 is giving us answer in the form of p? This means that 2 is a factor of p, right? Because something is getting multiplied with 2. That means 2 can divide p. So 2 is a factor of p. So let's write p as 2 into c, where c is some number which by multiplying with 2 gives us the answer as p. Let's write it in this equation 1. So our equation becomes 2q square equals to 2c whole square, right? So solving this, we get 2q square equals to 4c square. Now 2 can go there and divide and we'll get q square equals to 2c square. Now can you see that something is being multiplied with 2 to give us q? That means 2 is a factor of p as well. Sorry, q2 is a factor of q as well. But this is a contradiction, because if they have a common factor, then they cannot form a rational number. Remember, rational numbers are those which can be written in the form of p by q with common factor only 1 as their common factor, no other number. But here we see that 2 is a common factor of both of them. So hence our assumption is wrong and root 2 is irrational. So just as we proved that root 2 is irrational, in the same manner we can prove that root 3, root 5, root 7, all these numbers are irrational. Now another similar type of question which generally comes in the exam is that prove that 5 minus root 3 is also irrational. Now let, again the same assumption, let 5 minus root 3 be rational. Now since it is rational, so we can write 5 minus root 3 equals to p by q. Now taking root 3 on the side, p by q on this side, we get root 3 equals to 5 minus p by q. Now p by q is rational, 5 is a rational number, so their difference is also going to be a rational number, right? This implies that root 3 is equal to some rational number c by d. But this is a contradiction because we just proved that root 3 is irrational, right? Hence, we can say that 5 minus root 3 is also irrational. This is very simple. If it's of 2 marks, you can show it like this. If it is of 5 marks, you need to prove that root 3 is also irrational, just the way we did it for root 2. End of this chapter has a very interesting topic, which is decimals, basically types of decimals. We all know what are decimals. Decimals are numbers like 0.5, 0.35, 0.477744, 0.4388. All these numbers are called decimals. पर हमें decimals मिलते कैसे हैं? Decimals मिलते हैं when we divide the fractions. For example, we have 1 by 2. 1 by 2 is written as 0.5, right? We have 1 by 3. 1 by 3 is written as 0.3333 and so on. These are called decimals, which we get by dividing the fractions. Now decimals are of two types, terminating and non-terminating. As I given the example, 1 by 2 is 0.5. So यहाँ पे we get the remainder as 0 and the sum is over. So this is terminating decimal. But here 1 by 3, 3 is getting repeated, 0.333, there is no end. We'll never get the remainder as 0. So this is called non-terminating decimals. तो जिसमें रिमाइंडर 0 आ जाता है उसमें हमें मिलता है टर्मिनेटिंग डेसिमल, जिसमें रिमाइंडर 0 नहीं आता उसमें हमें मिलता है नॉन टर्मिनेटिंग डेसिमल. नॉन टर्मिनेटिंग डेसिमल को हम फर्दर डिवाइड कर सकते हैं रेकरिंग एंड नॉन रेकरिंग. जैसे इस एग्जाम्पल में 0.333, so 3 is getting repeated continuously, so this is recurring non-terminating decimal. एंड नॉन रेकरिंग है जिसमें कोई लेटर रिपीट नहीं हो रहा पर रिमाइंडर भी 0 नहीं आ रहा है. फॉर एग्जाम्पल 0.14368554, नथिंग इज गेटिंग रिपीटेड लेकिन रिमाइंडर भी 0 नहीं आ रहा है. तो दैट इज नॉन रेकरिंग नॉन टर्मिनेटिंग. Don't worry, we don't have to solve any decimal, we don't have to find any decimal by division, we don't have to do recurring and non-recurring. We just need to find out whether a given fraction will give you a terminating decimal and a non-terminating decimal without actually dividing it. So there's a simple trick to find it out. Look at the fraction very carefully. अगर जो डिनोमिनेटर है मतलब जो नीचे वाला नंबर है फ्रैक्शन का, अगर हम उसे 2 की पावर में कोई नंबर लिख सकते हैं या 5 की पावर में कोई नंबर लिख सकते हैं तो उस फ्रैक्शन का विल गेट अ टर्मिनेटिंग डेसिमल, अदरवाइज विल गेट अ नॉन टर्मिनेटिंग डेसिमल. फॉर एग्जाम्पल, आई हैव रिटन सम फ्रैक्शंस ओवर हियर. First one, 13 by 8. Now look at the denominator 8. 8 can be written as 2 to the power of 3. So this is a terminating decimal. This fraction will give a terminating decimal. Look at the 11 by 125. Again, 125 can be written as 5 to the power of 3. So again, power of 5. So it is a terminating decimal. It will give a terminating decimal. 6 by 14. Now 14 can be written as 2 multiplied by 7. That means 2 to the power of 1 and 7 to the power of 1. अब हमें 7 तो नहीं चाहिए, हमें सिर्फ 2 चाहिए या 5 चाहिए. So this will give a non-terminating decimal. Next, 3 by 10. Now 10 can be written as 2 into 5. So 2 to the power of 1 and 5 to the power of 1. तो इसमें 2 और 5 दोनों हैं. So it is a terminating decimal. So what do you think about 4 by 9? Yes, 9 is 3 into 3, which is 3 to the power of 2. So ये 2 के पावर में नहीं है, 5 के पावर में नहीं है, तो ये क्या होगा? Non-terminating decimal. Only this type of question will come in your exam. थैंक यू फॉर वॉचिंग द वीडियो टिल एंड. आई होप आपके सारे डाउट्स इस चैप्टर के क्लियर हो गए होंगे. मैंने सिर्फ इंपॉर्टेंट टॉपिक्स कवर किए हैं जो एग्जाम्स में आते हैं एंड दिस मच इज़ इनफ फॉर योर एग्जामिनेशंस. इसके अलावा विल बी कमिंग अप विद मोर वीडियोज़ ऑन रेस्ट ऑफ द चैप्टर्स. Till then, any suggestions, any query, please write it in the comments. Please like, share and subscribe to our channel Smart Education. Thank you. Take care. Bye.